Alrighty, hopefully you're clicking over here from the actual lesson on Intro to Transformations. I know it's a longer lesson, especially with that embedded Desmos piece, but it's also pretty thorough. So now we get a chance to see what you know, don't know. Like and subscribe if you find the video helpful. Drop a comment or a question, and check out the other videos and playlists we have on the channel. Without further ado, go ahead and pause the video to work these problems on your own, and then come back to check your work. As a quick clarification, sketch a quick graph. Here's what I mean by that. Something like that. Okay, like that kind of quality, caliber, and amount of time. So that did not take me long to do. Do not spend a lot of time trying to sketch a quick graph. Okay, all right, I'll see you in a few. Right, so for problems 1 through 3, it's just state the transformations from the parent function. A lot of times directions like this will just say state the transformations, because it will be assumed that, like, unless specified otherwise, we mean from the parent function. So for this first one, there's only one transformation on that, and that is down 3. So this -3 on the outside will slide the parabola down 3. Common mistake on something like that is a student thinking it can't be that simple. There can't just be one transformation, and we'll start to try to make there be other transformations. They'll say, well, it's a 1x, so that 1's got to do something, and the squaring's got to do something. No. All right, this is one transformation. Second one has 2 transformations on it. The negative out front will flip it over the x-axis, and the +5 will send it up 5. And so this is what we mean by state the transformations. Always follow your own teacher's directions, but your teacher's directions should be something similar to this. It's not going to be wildly different. Maybe they'll want you to use the word reflect instead of flip. Sometimes I always say over the axis, because that makes sense to me, but I have seen flip in the axis and flip on the axis, which sound weird to me. I don't know, flip in, like a reflection in. It seems like a weird word to use there. So I use over. Use what your teacher wants you to use. Now this third one has more transformations going on. So the 2 out in front, 2 is greater than 1. So we would say this is stretched, and you might need to add some more detail to that. So you might need to say stretched by a factor of 2, or stretched vertically by a factor of 2, maybe just stretched vertically. Typically for my classes at this level, I'm okay with just stretched, but I know teachers that I work with that might require more than that. The +4 on the inside is going to send it left 4, and the minus sign at the end will send it down 1. So the pieces we're looking at there's the stretch, there's the left 4, there is the down 1. Okay, so those are the pieces that we're looking at. Now, I gave some clarifications about this because I added in the direction to sketch a quick graph. One of the things that's great about transformations is it does allow us to get a very quick graph, not a super accurate graph, but a quick graph. So for these ones, here is at least what I was picturing in my head. So for number 4, you would start by stating the transformations. So I see that there is a flip. That flip is going to be over the x-axis, which is all I typically would do for a parabola, and it's going to go right 2. So here's what I mean by a quick graph. Mark off that it goes to the right 2 so that we can anchor that, and put the vertex down, and then make sure that whatever you draw is flipped over. Now, do I know for sure that that's going through all the right points? No, I don't. It's a quick graph. It gives me a quick idea of where on the coordinate plane it is and what orientation it has. For number 5, we have -3 x plus 4 all squared plus 3. So we start with the transformations. So we know this has a flip over the x-axis. We know that it is stretched, and that gets really hard to do when you're just doing a quick graph, like a super quick graph, because yeah, it's more challenging to do. But we'll do our best. The +4 means it is going left 4, and the +3 on the outside means it's going up 3. So for our quick graph, I am going to count left 4 and up 3 so that I can accurately, left 4, there we go, and up 3 so that I can accurately put the vertex there. It is flipped and it is skinny or stretched out. So when I go to draw it, I'm just going to try to draw it skinny. Okay, just show that I understand that this parabola is skinnier than normally like what I would draw. For number 6, so we have f of x is equal to 0.5 x squared plus 2. 0.5, that is a compression. So this one is going to be wide, like something pushing down on it. It is not flipped over, and you don't have any adding or subtracting inside the squaring, so there's no left-right on that, but it does go up 2. So when we go to do our quick graph, it's going to go up 2, and then I need to plot my vertex, and I'm just going to try to show like, yeah, this one is wider. Okay. Now, when it comes to doing quick graphs, a few things that I usually share with my students is avoid making, there's 2 mistakes that I will tend to take off for. One is if they draw the parabola looking pointy within reason. So I understand it can be hard to draw that and have it not look like it comes to a point, but here's what's not okay. Don't draw it looking like that. Okay, that's actually a different kind of a function. The other thing is don't let it look like the sides of the parabola are vertical. So it's not that either. That would mean it is not a function. So within reason, and usually like that vertical thing, what I'm seeing in my head is students who have a piece of graph paper and they clearly draw the sides of it so that they track onto the grid of the graph paper. Okay, the sides of a parabola are not vertical. They do continue to move like outward as you go across. So those are 2 things that would kind of be disqualifying on the shape of the graph. So just be aware of that. All right, now we get to the more interesting ones. So if a graph starts at 2, f of x is equal to 2x plus 3 all squared minus 1 and ends at g of x equals 2x plus 1 squared plus 1, what transformations were performed? So this is taking it off of the parent. Okay, so we're not starting the transformations at the parent. Best way to do this is with a graph, and you can use Desmos to do it, or you can do it by hand. Now, I did on purpose make the stretch on both of them too, because it gets harder to decide how do I want to explain this if you change that. So you could say like it made it compressed it or stretched it, and hopefully we don't want to get more specific than that. It starts though, if I look at this one here, it starts at left 3 and down 1. So what I'm going to do is come over here and say, okay, I'm going to go left 3 and down 1, and I'm going to make it like look skinny, but I'm not messing with that. So that's where it starts. It starts at left 3 down 1, and it ends at where is it? This puppy ending. It is ending at left 1 up 1, and so when it ends, left 1 up 1, and we haven't flipped it over or anything, and you can always add something in there that would show like it flipped or something, but I didn't throw that at you in this one. So the question is, what transformations were performed? How do I get from the red graph over to the blue graph? And so if I take a look at it, it looks like we went up 2. Okay, so what I'm doing is I'm tracking that vertex. So the vertex went up 2 and right 1, 2, 3. Oh, no, just 2. Sorry. 1, 2. So up 2 and right 2. And so the answer to that would be, to get from one to the other, we go up 2 and right 2, and you could say right 2 and up 2, but essentially what you want to do is to look at that vertex and just track, where did the vertex go? If it's flipped, that'll be pretty easy to see because it won't be oriented the same way. So it could flip from up to down or down to up, like it doesn't matter. And then if it got skinnier or wider, that's pretty much all I would say, is like it was compressed or it was stretched. I don't think I would venture into by how much unless my teacher absolutely required it. And that would be very advanced for Algebra 2. Not saying it's not anything you could ever see, but that would definitely be a more advanced question. Question 8, write the function for a graph that is compressed by a factor of 1/3 and shifts right 2 units. So this is switching the order around. Instead of you looking at a function and stating the transformations, this one, they're giving you the transformations and asking you to write the function, and unless it's stated otherwise, we assume from the parent. So to compress by a factor of 1/3, we would have multiplying by 1/3. To make it go right 2 units, that would be subtracting 2 on the inside, and that is it. So f of x is equal to 1/3 x minus 2 all squared. Now, question 9. Write the function for a graph that starts at, so now we're not starting at the parent function, it starts there, and then it flips over the x-axis and shifts down 4 units. Okay, so let's take a look at this. So let's go find where it starts. So it starts flipped, left 3 and down 1. Okay, so that's where we're starting. So 1, 2, 3, down 1. So left 3, down 1, and it is flipped over. And what we want to do from there is we want to flip it over the x-axis and then send it down 4 units. So let's go ahead and do that. So if I flip it over the x-axis, it's going to land up here. We'll do this in green. Okay. And so it's going to look like that. I'm going to do this dashed. Okay, so we did like a reflection over the x-axis, and then we're going to go from there down 4 units. So that's going to require me to put some extra things here. Here we go. So starting here, we're going to go down 1, 2, 3, 4. And so here's where we're going to land, right there. Okay, and so where do we, how do we write the function? You could write f of x or g of x. It is no longer flipped. Okay, so we're not going to have that. And then we're going to go down 4 units, which is going to send us, we're still x plus 3 all squared, but 1, 2, 3, we're just down minus 3, like so. Now this can get also dicey, like I'm sitting here thinking about it, and the order that you do those transformations does make a difference. So the way this was written, it says it flips over the x-axis and shifts down 4 units. If you were to shift that down 4 units and then flip it over the x-axis, you would end up in a totally different spot. So we can take a peek at that. If you were to take this and shift it down 4 units, so we go down 1, 2, 3, 4, it would put us like down here at 1, right here, down here at -5. So it would be like that. And then you reflected it. Now it would come all the way up here like so, and you would end up with this. G of x is equal to x plus 3 all squared, but instead of a -3, you're going to be up there at a +5. So the order that you perform those transformations matter. The way this one is written, it says it starts here and then flips over the x-axis and shifts down 4 units, which would be different from shifts down 4 units and then flips over the x-axis. So definitely something to be wary and cautious of, that the order that you perform those transformations does matter. Last one is write the function for this graph. I think I kept this simple for you, but like we'll kind of talk about it in detail. Kind of wish I had double checked this, but all right. So what I can see about this, I can see that there is no flip. Okay, so there's no negative. Whether it is stretched or compressed, that's the part that makes this really tricky. And I usually do not make this difficult for my students. So usually what I tell them is, if I'm going to give you a question like this, I'm not putting a stretch or a compression on it. If I were teaching a higher level Algebra 2 class, then I might, okay? It's just, that's like one of those like a level of complexity that can differentiate, say, an advanced class from an honors class from a standard class. Like, how complicated are you going to make this? I can see that this goes right 3 and that it goes down 4. So what I am sure of is this part. It goes right 3 and down 4. What I'm not sure about, though, is this. Okay, I'm not sure about, is there a stretch or a compression on there? So if you needed to know that, here's what you do. You find a point, okay, on the parabola. So we have a lot of points to pick from. So I see these points. So I have the point 1, 0, the point 5, 0. I see the point 2, -3. I see the point 4, -3. All of those look good. All of those look good. So I'm going to pick one, and what we're going to do is we're going to plug in the point, and we're going to see if we can find the value for A. So because I like simple things, I think that's the one that's going to come out the nicest for me, is the 5, 0, but any of these will work, okay? So what I'm going to do is plug in x is equal to 5, okay, because I have the x, y there. And so we're going to plug in 5 minus 3. Okay, but what is f of 5? In other words, if we go back to our mapping, what does the 5 map to? It maps to 0. So that comes in handy. 5 minus 3 is 2. And then we've got, remember this is multiplication here. 2 squared is 4. And I did that. That's awesome. Love that I did that. What color am I working in? That's a 0. All right, so this is really like 4a minus 4. So we're going to go ahead and add 4 to both sides. So 4 equals 4a, divide both sides by 4, and a is equal to 1. So my function would just be this, where the a value is equal to 1. And just so you can see that it doesn't matter which point we picked. So let's say you're like, I didn't know it was going to come out that way. I'm going to pick that point there. So if you were to plug in f of 2, okay, so now you have 2 minus 3 all squared minus 4. F of 2 is asking, what does it map to? It maps to a -3. So you got -3. 2 minus 3 is -1. -1 times -1 is 1. We'll add the 4 to both sides. -3 plus 4 is 1, and you get A equals 1A, so A is equal to 1. So it works for any of the points. Just plug it in, and if A were something else, if it was stretched or compressed, you could figure out what A is. That piece of it, that's a little bit more advanced. It's not super common, but if you move ahead in math, you might need to go through that particular step. All right, so that's it. Don't forget to like this video if you found it helpful, subscribe to the channel for more math content, and please check out the other videos and playlists on the channel, and let me know if there's anything you don't see that you would like to see. I will see you in the next video.